Okay, in this video I'm going to show you how to factor a four-term polynomial. Now let's talk a little bit about what that actually means. What does factoring mean? What's a four-term polynomial? That sort of thing. Maybe factoring would be better explained if I showed you a really simple example. Think of factoring as the opposite of distributing. Now what is distributing? Well, let's take a really simple example. Let's say I have 2 times the quantity x plus 4. When I distribute, I'm going to multiply this times the first term plus this times the second term. And that's distributed now. But look what I end up with. I end up with a polynomial. This is a binomial in this particular case. Factoring is how you get from the polynomial back to the multiplication. So it's the opposite of distributing. So here's my polynomial down here. It's 4 terms. And what I want to do is I want to get it to a form that's all multiplied. Okay? And I'm going to do it by a technique called grouping 2 by 2. And 2 by 2 means I'm getting 2 binomials, or 2 rather, binomials. There's the 2, and then the binomial would also means 2. So here's my 4-term polynomial. Let's talk a little bit, just a second, about what are the terms. Remember, polynomials are terms that are separated by additions and subtractions. So here is a term, 3 times x, plus 12 plus ax squared plus 4ax. 4 terms separated by additions and or subtractions. Now, if I want to group this, one of the possibilities is to take 2 different binomials. Remember, I like to say that difficult problems are just a bunch of simple ones that I've stacked together. The first thing I like to do when I see one of these 4 terms is to put it in correct descending order. So let's go ahead and try that. Remember how you do that? You look at the letters of the alphabet first. In this case, I have the A's, so these would come first. It just so happens that both of these are a to the first, so they're tied, so to speak. So what comes next? What do I look at next? Well, I look at the next letter in the alphabet that they both have. In this case, it's the x. Now, in this one, there's an x squared and next to the first. This would be the correct first term to put in my polynomial, my ax squared, because it's greater than x to the first, right? So then I'm going to put the next one, which is 4ax. Then I go to 3x, and then I go to 12. The constant, or a number, is always going to be last in putting it in correct descending order. Okay, now that I've done that, I'm going to group them into 2 different binomials. And here's my first binomial, and here's my second one. Again, I'm going to say that difficult problems are just a bunch of simple ones stacked up. So let's factor this binomial by itself. Cover this one up and say, okay, what are the common factors in this binomial? It looks like it's the a times the x. So let's pull that out and let's rewrite what's left over. It's going to be x plus 4. Okay? And I have a plus sign. Let's bring that down. And now I'm going to treat just this part, this binomial here. Now what's common to 3x plus 12? Well, the common factor is 3. So let's pull that out and let's rewrite what's left over. That would be x plus 4. Interesting. Now look what I have. I have ax times x plus 4 plus 3 times x plus 4. Here's the tricky part. This is a type of binomial. But you're probably wondering, wait a minute, why is that a binomial? I've got lots of nomials in there, so to speak, don't I? Well, remember what a binomial is. It is 2 terms separated by an addition or a subtraction. Now, what's a term? A term is a collection of variables and numbers separated by multiplications. So here I've got a times x times the quantity x plus 4. You got to treat that together as one thing. So that's really just a multiplication, isn't it? And there's my separator, there's my addition or subtraction, and in this case I got the same thing, 3 times the quantity x plus 4. So really, in a sense, I've got a type of binomial here, don't I? Now, if I have a binomial, how do you factor a binomial? Well, you ask what's common to both sides of the addition in this case, right? So what's common here? What's common on both sides of that addition? You can see it's the x plus 4, isn't it? So let's pull that out. Just like we pulled the 2 out of here, let's pull the x plus 4 out of there. Now what's left over? Cover up what you took out, and you'll see that it's ax plus 3. ax plus 3. That is your final answer. And here's your final factored form. Because remember what factoring is. It's trying to change a polynomial into some kind of a multiplication. It's just reversing your distribution. Now, how do we know that this is correct? Let's check it. Well, I could do a quick FOIL on this, couldn't I? What's x times ax? That's ax squared. What's x times 3? It's plus 3x. What's 4 times ax? It's plus 4ax. And finally, what's 4 times 3? It's plus 12. And if you'll notice, that is the same thing as my original, except it's not in the same order. But that's okay, because I can use the commutative property to move things around and put it in correct descending order. Okay, I hope that helped. You can play this a couple of times until you get the idea. This is probably the most difficult part to see, is to see that as a binomial. Some people ask me, well, why don't I write this twice, for example? The same reason why you wouldn't write this twice up here. When you take the 2 out of both sides, you just rewrite it once, and then you write what's left over. You do the same thing down here. You take this out, rewrite it once, and then rewrite what's left over. Okay, good luck on this.